Namaste and a warm welcome. Today our topic of discussion is Uart using ESP32 and ESP-IDF platform. So first of all, let's start with the schematic of our ESP32 dev kit board. So the schematic is pretty simple. We have a micro USB through which we can power the device, as well as it is also the mode of transferring the code to our main chip. So this one has a D-, D+, and a VCC ground pins. Next we have voltage regulators, simple AMS 1117, 5.0 and 3.3 voltage regulators are present on the board. Next we have boot and enable buttons, and our main MCU sitting on the board with an RF shield. Next we have a indicator LED on GPIO pin 2. We have already covered how you can start up with your LED blinking code in a previous video. Then we have the most important chip, CH340G. This one is a USB to TTL based converter, and our TXD0 and RXD0 pin on the chip are connected to this chip, and D+, D- is also connected to this chip. Thereby this particular UART pins are responsible for uploading the code to this MCU chip. We won't be using that UART, we would be using another one of the UART. So ESP32 has up to 3 UART hardware UART available, and we'll be using UART number 1. We have already covered how you can create a new project. You just have to hover over to the espressif icon, move on to new project wizard, name your project, choose the directory, choose the component directory, and then go to choose template. Next in ESP-IDF, you have to hover to peripheral section now. Under UART, we are going to look after async RxTS task example. So I won't be creating it, I already have the example open in another window. This example uses GPIO number 4 and 5 as transmit and receive pin respectively. We have a very simple init function in which we have a UART config structure, which is responsible for all the configuration parameters, and you can have a look at what has been set already in the example. We'll go with the default configuration. Next you have UART driver install, UART param config, and UART setPin functions. You can have a look at these functions on the main espressif website, or you can also click go to definition. So UART driver install is pretty simple function responsible for installing the basic UART driver and setting up the default configuration. Have a close look that in the TX buffer size it is set to 0. It is set to 0, so driver will not use this, and this would be a blocking task for transmitting. So then we have a simple param config. You configure the structure, then we'll be allocating all the pins. Next in the main section we have init, we have already discussed that. Then we have xtask create. Xtask create is nothing but a freeRTOS API responsible for creating a new task. You can have a look at all the parameters of this particular API. We have PV task code, EC name, stack depth. One thing about stack depth is that in the vanilla freeRTOS, it is the number of words that would be allocated for this particular task, but in ESP-IDF, I guess it's the number of bytes. We won't be sending any parameters to the task, we will be setting the priority, no handle for this particular task. So this is a pretty simple task, and we have another task for transmitting. So if you have a look at the respective task functions, it has a while one loop, which implies it's an infinite loop. So this is something that has to be looked into freeRTOS task. Next up, the send data is a pretty simple function which uses UART write bytes, simple example. And you have to carefully understand that this function blocks your particular code. So until all the data has been transferred to TXV4, you can't do anything further. So next is a 2-second delay in the TX task. And in the RX task we have a simple dynamically created variable data, and we read the bytes into that particular variable and print it out through the serial monitor. So this is the basic crux of this example. Alright. Next up we'll build the code. Once it's completed, we'll flash the code. Once we are done with flashing the code, we'll monitor the code with the command that we have already discussed in an earlier video. Alright, so for this example's sake, what we'll be doing is we'll be shorting GPIO 4 to GPIO 5, and whatever is sent would be received back on the serial monitor. In order to analyze the data, we would be connecting a logic analyzer in series. So let's have a look what it has to say. So we would be going with async serial in the analyzer, and the channel that we'd be selecting would be channel 0, setting the baud rate to 115200, and then clicking on the run button. We can have a look at the data. So first data is 0x48. Let me open the calculator and have a look at it in binary. So since we are sending this data in LSB, which is least significant bit first, let's analyze it. So it's correct, 0 0 0 1, then 0, then again 0, then 1, then 0. So this is the 0x48 in binary format. Next, let's have a look at what this is in the ASCII table. So this 48 stands for capital H. Then we have small e, which is nothing but hex of 65. Next we have two double L's in small, which is nothing but hex of 6C. Next is small o, hex of 6F, and so on. So this was the bit mapping of your UART data. Hope you learned something out of this video. The same message repeats itself. Do subscribe the channel, like and share the video. Thank you.